All right, this is 13.6, triangles on a coordinate plane. This is going to be a good one. Should be pretty much a review for most of you guys, but let's get right down to it, okay? So we have let's say we have I don't know, uh, let's see, where'd my mouse go? Here we go. We have a triangle. Yep, and it starts at, we'll say -6. I don't need that yet. -6, negative 1, 2, 3, 4, 5, 6, and 3. 1, 2, 3. And so that point is -6, 3. -6 comma 3. Sorry, not a triangle, line segment length. Line segment length, and it ends at -2 or 0, -2. 0, -2. And we're like, hey, find the length of this. Okay, this is pretty simple, right? You might remember the line distance equation from algebra, but you don't. Maybe if you don't, that's okay. You can use Pythagorean's theorem, right? Because you can identify and use a right triangle to figure it out, because that's where it's derived from. Okay, so my change in x and y are what is used to make myself a right triangle. Okay, I'll make my red up and down, my change in y, and I'll make my change in x left and right. Okay, and I don't even have to count blocks. Okay, my change in x, I really only need the absolute value of it. So I'll put my change in x inside my delta. I made that bigger. There's no reason to make it small. All right, so my change in x, the absolute value of it, is going to be 0 minus 6, right? Is going to be -6, or minus -6 is 6, right? But it's going to be 6. So this line is 6, okay? And the absolute value of my change in y, right? My absolute value of my change in y is -2, between -2 and 3, and the difference between -2 and 3 is 5. Okay, there's 5 units between -2 and 3. There's 2 up and 3 down, right? So that's 5. So if you remember Pythagorean's theorem, the hypotenuse of this is going to be equal to the square root of both of those legs squared and added together. All right, so it's going to be 5 squared plus 6 squared, which is going to be equal to the square root of 25. Oh, it should be red. That's okay. 25 plus 36, which equals to the square root of 61. And I'm good with keeping that at the square root of 61, because that's a prime number. All right, so it always ends up being like 7.8 or something like that. But square root of 61 is good for me. Okay, so use your coordinate planes to make yourself a right triangle to figure out the length. That's just your change in x minus your change in y squared plus your change in x squared. Take the square root of it, and it's just the absolute value. All right, so just figure out what the distance is between your x and your y value every time. No problem. Easy day. Okay. All right. Now let's say it's not as easy, and they give me 3 points. Let's say they give me point B, which is -1 and 4, for instance. They give me point C, which is -6 and 1. And they give me point D, which is -3 and 9, and those all make a triangle. Right, so I got point D, which is -3, and 1, 2, 3, 4, 5, 6. I'll make it -6 so it doesn't go off scale. -6 well, I'm gonna make these 2. Each one of these units is gonna be 2. All right, so -6 and 9. All right, so -3 and 2, 4, 6, 8, 9. Okay, it's gonna be like right there. Well, that's my D. That's my point D. And then I have, that's -3 and 9. And then I have -6 for C is gonna be -2, 4, 6, and 1. That's gonna be right there. That's gonna be point C. And then I have -1 and 4. 1, 2, 4. So this is my triangle. Okay, now I'll go ahead and connect some dots here. Little small because of the limitations of my graph paper that I made. But this is my triangle. Excuse me. Okay. So, and I'm told that this is a 90-degree angle. Okay. All right, so how do I find these line segments? This is a little bit more challenging. Oh, this is a line segment C or D. This is B. Right, leading me with this is B, little b, this is little d, and this is little c. Okay, so, well, this is a little bit more challenging here. So, well, I need to make my own triangles again for each one of these line segment lengths. Okay, so I make myself a triangle for CB. I make myself a triangle for, I guess I'm calling that a little d, little c, and little b. Okay, so we'll just do little c first. Little c, right, is going to be equal to the square root of where my what's my change in x, right, for little c. My change in x for little c, we're looking at d and b, right? So it's going to be the difference between -3 and -1, right? So my difference between -3 and -1 is 2. So it's going to be 2 squared, plus my difference in d and b between 4 and 9. Right, so the difference between 4 and 9 is 5. So 5 squared, right? So that's going to be, wait a minute, I copied down some things wrong. -1, 4, -3, -1. Did I pause this? Just a second. Let me look at something real quick. Nope, everything's good. All right, so dB is 2 squared is 4 plus 5 squared is 25. So this is going to be equal to the square root of 29, which I'm leaving it the way that is. Okay, so that is C. So C equals that. All right, now I'm going to find B next. So B is going to be equal to, this is going to be C and D. Right, I'm looking at C and D now. My change in C and D, right, this is -3 and -6. The difference between -3 and -6 is 3. Right, so that's 3 squared. Okay, and then the difference in my y's, so 3, and my x value is 3. I'm looking between here and here, that was 3. Okay, plus my change in y's, which was, I'm looking at C and D, right? Yep, C and D is C and D. That's the difference between 1 and 9. 1 and 9. Right, so C and D, is it -1 and 9? C and D. Looks like negative 1 and 9. Making sure I didn't plot that wrong. C, no, it's 1 and 9. C, oh, C and D. C and D. I plotted that as a negative 1 and 9. I need to change this. That's what happened when you use the. I knew something looked funny. 1 and 9. That's why I was confused. 1 and 9. So C is negative 6 and 1. That's what looked funny. Okay. Man, alright, that looks better. Sorry about that. You know, even though I plotted it wrong, I was using the coordinate points, and it still is coming out right. Okay, this is C. This is C. So, let me fix all my errors. That's the advantage of using the coordinate points. That you, when you do the math, instead of using block counting, if you count the blocks, or if you make an oops like I just did, you still get the right answer. So anyway, so B, it's C to B is negative 6, that's 8. 8 squared. Because I was looking at that before, I was like, wait a minute, that's 10. But the actual thing is 8 squared. That looks more like a right angle. Okay. All right, so 3 squared is 9, plus 8 squared is 64. 9 plus 64 is 73. So this will be the square root of 73. And finally, we have D. So D is going to be the square root of our difference in x and difference in y of C and B. We got C and B. So the difference between negative 5 and, negative 1 and negative 6 is 5. And we're going to square that. And our difference between 4 and 1 is 3. So that's going to be 15 plus 9 is 34, and that's the square root of 34. And that is the answer to all those lengths. Okay, so that is that one. Let me pause and find another example. Well, actually, that pretty much sums it up. Just one thing to note, you're going to be asked like what type of triangles you might find, and when you find the different lengths of the line segments and you're comparing them, right? If all the line segments are the same length, it's equilateral. If you have two of them that are the same lengths, it's a nice isosceles triangle. And if none of them are the same lengths, it's a saline triangle, right? So all equilateral. Two isosceles. None scalene. Maybe I even said that wrong. All right, so that will help you with 12 or 13.6.